All right, so this is the Chapter 18 Sample Means and Proportions activity. So what you're going to do is you're going to go through each one of these. You have to first decide, are you dealing with proportions or are you dealing with means? And then you're going to go through and you're going to work each one of the problems. So number one, it says a survey asked a random sample of 1,500 adults in San Antonio if they support an increase in sales tax from 8.25 to 9%, with the additional revenue going to education, teacher bonus checks at Thanksgiving time to buy a real turkey instead of substituting freshmen. Suppose 30% of all San Antonio adults support the increase. What is the probability that more than 32% of all San Antonio adults support the increase? All right, so we're going to divide our problem up into our 4 quadrants so that we can go through our steps. So the first part is we're going to find the mean of p hat, the sample and proportions. Now, how did I know that I'm dealing with proportions? Is because I was given a percentage, right? This 30%, 30% of all San Antonio adults support the increase. So that is going to be our population proportion, which is p. The 1,500 is our n. And then the probability that more than 32% of all San Antonio adults support the increase, this right here is going to be our p hat from the sample. All right, so this is going to be 30%. Then our standard deviation of p hat is going to be the big square root. We do 0.3, 1 minus 0.3, all over 1,500. Put it in the calculator, and 0.018. So that's our mean, and that is our standard deviation. Okay, so in step 2 is we've got to check to see that our conditions are met. So our conditions are, we want to see that we have taken a large enough sample. So how do we determine what is large enough? Well, for proportions, we're going to do n times p greater than or equal to 10. And we have to do n times 1 minus p greater than or equal to 10. So our n is 1,500, our p is 0.3, and then that is going to give us 450, which is greater than or equal to 10. So then I'm going to do it again. So remember that this is an and, not an or. So we have to do 1,500, and I have to do 1 minus 0.3, and see if that's greater than or equal to 10. So I have 1,050, which is greater than or equal to 10. So now I know that it's large enough. And why is that important? Because that tells me that now I'm approximately normal, so that now I can move to box 3, where I'm going to write my probability statement so that I can use a z-score. Okay, so I want the probability of x being greater than 0.32. Okay, so I've got to change that to a z-score. So z being greater than 0.32 minus 0.3 divided by 0.018. That gives me a z-score of 1.67. All right, so then in box 4, I want to calculate the probability, right? I'm going to actually calculate it. So now I have my curve, and I have 0, 1, 2, 1.67 is about here. I'm doing greater than that, so I'm shading in this. So how do I go about calculating that? I'm going to go to normal CDF, and I'm going to go from 1.67 to positive 99. And then I'm going to get 0.047, which is about 4.7%. All right, so keep going. I'm going to go on to problem number 3. All right, so number 3 is the distribution of actual weights of chocolate bars produced by a certain machine is normal. That's important. It has a mean of 8.1, so that's our mu. And a standard deviation of 0.1, that's our sigma. If a sample of 5, there's our n, of these chocolate bars is selected, the probability that their average weight is less than 8 ounces. Okay, so we're going to divide this up again. Now I'm dealing with the land of means. Okay, since they told me the mean and the standard deviation, so now I have in the first box my mean, and it's x bar this time, is equal to the population mean, which is going to be 8.1. Then I have my standard deviation of x bar, which is the population standard deviation over the square root of n. So my population standard deviation is 0.1 over the square root of 5. So I'm going to get 0.045. So I have my mean and my standard deviation. All right, so then number 2 is I have to check my conditions. So my conditions are I need to see if this thing is approximately normal, right? And so in order to do that with means, first I have to check to see if my population was normal, which this said that it was normal. So my population was normal. So then it doesn't matter what sample size I took, which is a good thing, right? Because I'm only taking a sample size of 5. So I don't have bigger than 30, to use the central limit theorem. So I've got to be happy that my population was normal that it came from. So we're going to say that the sampling distribution of x bar is approximately normal because the population it came from is normal. All right, so we're good to go. So now that we know that our sampling distribution of x bar is approximately normal, now we can go ahead and calculate the probability. So part 3, we're going to write our statement, right? Our probability statement. Okay, so we're going to write the probability that the average weight is less than 8 ounces. So now I've got to convert that to a z-score. So the probability of z being less than 8 minus 8.1 over 0.045. So now I get a z-score, so the probability of z being less than negative 2.22. Okay, so number 4 is we're going to calculate it. So again, my little curve, 0, negative 1, negative 2, negative 2.22 is way over here. Shade that in. It's pretty small. So it should be a relatively small percentage out there. Okay, so to calculate that, I'm going to go to normal, CDF, and I'm going from negative 99 to negative 2.22. And that gives me 0.013. So I have a 1.3% chance that their average weight is less than 8 ounces. Okay, so I'm going to turn the page, and I'm going to go to number 6. All right, so success. Suppose that 45% of all adult women think they do not get enough time for themselves. An opinion poll interview 1,015 women and records the sample proportion. Describe the distribution and find the mean and the standard deviation of the sample. Okay, so describing a distribution means that we have to do the center, we have to do the spread, and we have to do the shape. So first of all, I have to think about what land I'm in. So I'm dealing with percentages, so this means I'm in the land of proportions, right? Okay, so I'm going to start with my center. Okay, so my center is the mean of p hat, which is equal to the population proportion, which is going to be the 0.45. So then I have my spread, which is my standard deviation of p hat, which is 0.45, 1 minus 0.45, all over n, which this 1,015 is going to be Rn. Put that in the calculator and I get 0.016. All right, and so then the final thing that we have to do is our shape. So this comes from checking the conditions, right? And so for conditions for the proportions, right, we have to check that n times p greater than or equal to 10, and I have to check n times 1 minus p is greater than or equal to 10. That's going to tell me that it is large enough, okay, and it's approximately normal. So I'm going to take 1,015 times 0.45. That's going to give me 456.75, which is greater than or equal to 10. So I'm good. So I have to do it again, 1,015 times 1 minus 0.45, and see if that is greater than or equal to 10. So I have 558.25 greater than or equal to 10. And so I am good to go. Okay, so then we're going to say the sample size is large enough. The sampling distribution of p hat, because we're talking about proportions, is approximately normal. Okay, so let's do one more. We're going to move to number 8, and then your job is going to be to finish these up. Okay, so we've got the average age of cars owned by residents of a small city is 5 years with a standard deviation of 2.1. Okay, so they gave us the average, right, which another word for that is the mean, and they told us it was 5 years, so that's mu, and then the standard deviation is 2.1, so that's going to be sigma. So a simple random sample of 400 cars, this is going to be our n, is selected, and the sample mean age computed. Describe the distribution, the mean, and the standard deviation of sample means. Okay, so this is just like we just did on the last problem, but now we're in the land of means, right? Okay, so we're going to start with our center. And so now we're doing the mean of x bar, which is equal to mu, which is going to be 5. Then we have our spread. So standard deviation of x bar. So it's a population standard deviation over the square root of n. So our population standard deviation was 2.1 over the square root of 400. So that's going to be 0.105. And then the last thing is the shape. And then, so our shape is with this one, so with the means, right? We have to see if our population is normal, right? And if the population is normal, we're good to go. And then the other thing is if it doesn't say our population is normal, which it doesn't in this problem mention that the population is normal, then we have to look for our n, right? And we have to check to see if it's bigger than 30. If it is, then the central limit theorem kicks in. Well, 400 is definitely bigger than 30, so we're good to go, right? So we're going to say since n is bigger than 30 by central limit theorem, the sampling distribution of x bar is approximately normal. All right, so then you're done with that. So now what you're going to do is you're going to go back and you're going to finish the ones that I didn't do, and then you will turn this in when you're done. Email me if you have any questions.